Section 3.7, example 51, evaluating an improper integral from negative infinity to infinity. So evaluate this integral, state whether it converges or diverges. Ooh, okay. So let's pick an easy number. So we could definitely go like the interval from negative infinity up to a, plus from a to positive infinity. But let's just choose a because we are continuous on the entire graph here. So all real numbers are eligible here. So what we're going to do is just integrate up to 0. So we'll say from negative infinity to 0 of x e to the x dx, plus from 0 to positive infinity x e to the x dx. And now that we have that, let's set up the limits. So we have the limit as, we'll say a approaches infinity, or actually negative infinity, from a to 0, x e to the x dx. And at the same time, we'll evaluate the other integral. The limit as b approaches infinity, from 0 to b x e to the x dx. And now we just have to evaluate these values. All right, so it looks like we could use our integration by parts. So we'll say let u equal x, dv equal e to the x dx. And that's going to be for both of them. So we could kind of put these in the middle here. du is going to be equal to dx. And v is going to be equal to e to the x. And kind of separate these a little much better. So now from here, copying everything down, we have the limit as a approaches negative infinity, from a to 0. Actually, let's just start evaluating that part. So u times v, x times e to the x, minus the integral of v du, e to the x dx. So that's this part. And actually, let's do a little color coding. We'll make this one a little bit darker. All right. So it was this one. Let's add this one. So the limit as b approaches infinity of x, so u times v x e to the x minus the integral of v du e to the x dx. So let's get this one. The limit as a approaches negative infinity, x times e to the x minus the integral of e to the x is going to be negative e to the x. And here we're evaluating from a to 0. So from a to 0, plus, let's get this one done. The limit as b approaches infinity of x e to the x minus the integral of e to the x, which is e to the x. And this one was from 0 to b, so from 0 to b. All right, over here, let's evaluate. So the limit as a approaches negative infinity, we have 0 times e to the 0 minus e to the 0. And we're evaluating that up to a. So we have a times e to the a minus e to the a. We got that part. Let's add this next part. So this is going to be the limit as b approaches infinity of b times e to the b minus e to the b minus 0 e to the 0 minus e to the 0. So now evaluating, I'll do this in gold. So we have 0 minus 1 minus infinity minus infinity. Not looking good. Plus infinity minus infinity minus 0 minus 1. So either way, we have infinity here. We have infinity here. We have infinity in multiple places. So we cannot say that this converges to any one single value. We have to state that it diverges. So diverges to infinity. Sadly. And that's it here. If you have any questions whatsoever, please do not hesitate to ask. Otherwise, bye.